Hello everyone, this is lesson 5 of Machine Learning Zoomcamp session 5, and in this lesson we will talk about managing virtual environments, and we will talk a tool for doing that called Pipenv. Let's say we want to install a library. So by now you know that if you want to do this, what you do is you do pip install and then library name, for example, scikit-learn. So when you do this, what happens is your system where you type in this command, it looks up in this path variable and it sees what kind of pip you're talking about. And let's say if you use Anaconda for this lesson, so then pip usually is coming from your home directory. Then you have Anaconda 3, and then there is a folder called bin. Then in this bin, you have pip, you have Python, and you have other things, right? So when you type pip install scikit-learn, so it uses pip from this location or whatever location you have on your path variable. It uses this pip, and then this pip goes to pip.org, which is the Python package index. It's Python PI package index. So then it finds scikit-learn here, and it installs the latest version, because here you notice that we don't specify a version here. That's why it's the same as installing the latest one. So you execute this command, pip goes to pyp, it fetches the scikit-learn wheel or some other format. So there is some package, and that it installs back to the Python that you have on your path variable. So it goes somewhere in this Anaconda folder. There is a folder for your libraries, and it goes there. And let's imagine a scenario where we have two applications. So we have churn service, and let's say our churn service uses scikit-learn 0.2042. And by the way, this is how you can specify the exact package. So let's say if you want to use pip to install an exact version of a package, you write pip install scikit-learn, and then you use equals, and then the version you want to install. So churn service needs scikit-learn of this version, but let's say we have some other service, let's say lead scoring. So lead scoring service, a service that we use to estimate what is the probability that this potential client will become an actual client. And for example, this lead scoring service uses scikit-learn of the latest version. So it uses scikit-learn 1.0. And if we have two such services in our system, our churn service depends on this version of scikit-learn, and lead scoring service depends on this scikit-learn. And these are two different versions of scikit-learn. So for example, in this version, there is something new that doesn't exist here. So that is why we need to make sure that everything that the lead scoring service needs is there. And at the same time, there could be some things that were removed, for example, from this version of the library. We still need to make sure that the churn service still keeps running, right? So we need to find a way to keep them separated. Because if we just use the system Python or whatever Python we have in our path variable, we're risking that if we need to run two projects, they will have conflicts. So here, this is actually a conflict. So they need different versions of a library. To solve this problem, what we usually do is we use virtual environments. The idea there is we put these two different services into different virtual environments, and they stay separated this way. So each virtual environment has its own libraries, its own version of libraries, and these services do not depend on each other. So let's say we have our churn prediction service, and we have our lead scoring service. So each of them lives in its own environment and isolated from the rest. So for example, for churn service, it uses its own Python, which can live, for example, in somewhere venv churn bin Python. And the lead scoring service has its own Python that lives in venv lead bin Python. So they have different Pythons. Each of these Pythons has its own packages. So, and when we do pip install here, it uses pip from here, right? And then it installs a package. When we do scikit-learn, then it installs this scikit-learn to this Python. And the same happens for the lead scoring service. When we do pip install here, then it uses this Python, its own Python. And when you install scikit-learn here, you can install a different version of scikit-learn, which will have no conflicts with the churn service. So here we have no conflicts. So this way you can keep these things separated. So the churn service will have its own dependencies and its own environment, and the lead scoring service will have its own dependencies and its own environment. So this type of separation, so remember, these things, they still live on the same computer. So they still, like, let's say this is your laptop. Say if you use Ubuntu, so both of them live on the same laptop, on the same operating system, the same Ubuntu. They just have different, let's say, folders where they keep dependencies. And this is how they manage to resolve the conflict. So each of them keeps their own personal Python that is isolated from the Pythons of other projects. This separation is called virtual environments. And there are multiple ways of managing virtual environments. So you have the more classic Python one. It's called virtual env. I think it's a built-in package for Python called venv that you can use for creating environments like that. And then there is also Conda. This is what Anaconda uses. And if you were following the instructions from the setup, let me quickly open them. So in Zoomcamp, in our first introductory session, we had this environment. And yeah, so you can create environment for this course. And Conda here was creating a virtual environment. And this virtual environment was isolated from main Anaconda Python interpreter, right? So here we activated the environment. So this is, you can use Conda for that. And then there are other libraries. One is Pipenv, and then there is also Poetry. In this lesson here, we will use Pipenv, but it's pretty similar to Conda or Poetry, so there are no big differences. So the only reason I chose Pipenv is it's officially recommended package management from the Python community, but they work pretty similar. And I think Poetry is considered more cool, but I think at the end they work in exactly the same way. So we will cover Pipenv here. And as I said, Pipenv is a way to manage these dependencies of different versions and manage these virtual environments. Okay, so now let's install it. Before this lesson, I deleted it, so hopefully it should install it. Pip install pipenv. This is how we install pipenv. On Windows, it's the same. So just do pip install pipenv. So we have pipenv here, and now I am in this folder. Now to install a package, what we do is instead of using pip install, let's say NumPy, we use pipenv install NumPy. And then for this project, we need NumPy. Then we don't need pandas, we need scikit-learn. And actually for scikit-learn, we need a specific version. Remember we had this warning. So it's when it was trying to unpickle an estimator of this version. So we don't want to have this warning in production. So that's why we want to specify the exact version of scikit-learn here. And then we need Flask. And this is how we install libraries. It's pretty much similar to pip, except here instead of using pip, we use pipenv install. Let's install it. And you see it's installing the exact version of scikit-learn that we specified. It has created two files, Pipenv, Pipfile and Pipfile.lock. We will now look at these files. So see that there are two new files, Pipfile and Pipfile.lock. And it was also referring to these files here during the installation. So creating pip file for this project, adding things to Pipfile, and then creating a Pipfile.lock. So let's look at these files. So let me open my Visual Studio Code. Let's start with Pipfile. So we have Pipfile here. So you see, this is how a pip file looks like. So here we say which packages we need. So we say that we need a package called NumPy, we need a package called scikit-learn, and we need a package called Flask. And for scikit-learn, we specify the exact version of scikit-learn that we want to have. So we specify the exact dependency. And we will come to dev packages a bit later. So dev packages are basically packages that you only need for development. So you only want to have them on your laptop, but you don't want to have them when you deploy your service production environment. We will see an example of a dev package in the next lesson. So this is how our pip file looks like. And you also remember that we need to install gunicorn. If you're on Windows, you want to install Waitress. So we do install gunicorn. And what should happen is yeah, you see it added a new line here in pip file. It edited this file, and we save everything to Git and clone this repo on a different computer. Let's say our colleague wants to start working on this project. What they do after cloning is they just do pipenv install, and that's all they need to do. So they don't need to write all the names of the libraries. Pipenv will use the Pipfile and Pipfile.lock, which we'll look now, to figure out which dependencies it needs to install. So now let's take a look at this Pipfile.lock. So this is a JSON. It's a big JSON file, and what it contains versions, exact versions for every dependencies we have. So let's say we have Flask. Here it specifies the exact version of Flask that was used. So this version of Flask was used for this project, and this is the checksum for the files that Pipenv downloads, and this is needed to avoid any surprises. So it kind of fixes, it pins the versions, and when you do Pipenv install, it makes sure that these exact versions are used when you create this virtual environment on a different computer, and this helps with reproducibility. You make sure that dependencies that you have on your machine will be exactly the same when your colleague tries to install it. So this is very important for reproducibility, and it helps avoiding some nasty bugs with version compatibility and with when a new version is coming out that changes something in the behavior. You want to avoid such surprises, and that's why you want to pin your dependencies. And it does that for all the dependencies basically. So you see like NumPy, so specify the exact version of NumPy. These are all the files that NumPy has. So this is the purpose of the log file. And when you do pipenv install, it tries to install things from Pipfile.lock, and it looks at the exact versions, because here we have the exact versions, and then it tries to install these exact versions. So this is how we install packages with Pipenv. And yeah, let's say we install these packages. So what we now want to do is, let's say if we want to run our service, right? So what we want to do now is we want to get in this environment, right? So we want to get in this environment, and let's say when we run Python predict.py, we want to make sure that this Python is used and the dependencies for this particular service are used. Not dependencies from this project, not dependencies from some other project, but dependencies from this specific project. And for that, we use pipenv shell. And this way so it says launch in subshell in virtual environment, and it actually shows which folder is used for storing this virtual environment. So it's actually, so we can see what is here. So it has this bin folder, right? And bin, we have Python, we have pip, we have other things. We also have gunicorn because we just installed it. So when we write now which gunicorn, it points to this location. So when we type gunicorn here, then this gunicorn will be used, right? Because now I think if we do echo path, the first thing in our path is exactly that. This is how virtual environment is making this happen. So it prepends, it adds this virtual environment at the beginning of our path variable. And that's why first, when it is looking for gunicorn, it goes to this folder first. And when we type gunicorn bind, then address 9696, and then predict up. So now it actually uses gunicorn from this virtual environment that we created. And yeah, it uses this Python file and it uses this variable for creating a web service. And let's call it. I'll go to Zoomcamp again. And here we have this predict test. I remember. So this is something we used for testing. So let me execute this predict test, and then yeah, so it says that for this customer the probability of churning is quite low, so it actually used this thing that we deployed here. Let me stop that. Yeah, and to exit this shell we just do Ctrl-T, it leaves, and now we are back. So if we check which gunicorn, so now it uses a gunicorn that I had previously installed, and which Python, yes, it uses the same. The previous Python that I used, it doesn't use the virtual environment anymore. So first, like if we want to run something, we need to do pipenv shell and then do Python, I don't know, gunicorn something. That is too much to write. So what we can do is just write pipenv run and then the command. And then what will happen is pipenv will execute this command, this line inside the virtual environment. So basically this is the same as doing pipenv shell first and then running gunicorn bind, etc. Okay, I think that's it for this lesson. So in this lesson, we talked about virtual environments and we talked about Pipenv as a way of managing virtual environments. So we talked how to install Pipenv, we talked how to install libraries with Pipenv and how to run things with Pipenv. So this thing creates virtual environments. So the way it does this is by prepending things to the path variable, and it just places dependencies in different folders. But we're still running on the same laptop, on the same host machine, on the same Ubuntu. So yeah, they're still not very separated. And if one service needs some specific version of some specific system library, like, I don't know, OpenMP or something like this, which is not a Python dependency, but some system dependency that you install with, I don't know, apt-get install libgomp, for example. Yeah, and if these two services need different system dependencies, we're out of luck. Virtual environments will not be able to help us here. So for that, we need one more level of isolation between things. And this is what we will look at in the next lesson when we will talk about Docker.